Yeah, right. So yeah, I started in the industry when automation was a thing. So in 1990, and I worked with GEC, and I worked my way through the steel industry in the UK, automating things, which meant really putting PLCs in and doing some simple models. I then moved to working for Tata Steel, Chorus as it was at the time, and started to understand the process and understand really what we should have been doing with automation and what we should have been doing to make money. So I went through that and I moved into doing large capital projects, which is actually sort of delivering things. So I'm not a metallurgist. I'm not going to talk to you about metallurgy. What my sort of DNA is delivering projects and trying to do things now. So what I've got is a selection of things that ABB are doing now. And I'll talk through the sort of thing we're trying to do to support the sector. So if we just start off, ABB is a big company. I'm sure everybody knows it's a big company, but just to show how big it is, there's 105,000 employees. And we work across lots and lots of sectors, metals and mining being just one of them. We supply products, but more importantly, for the metals and mining sector, we supply solutions. So quite a big company, difficult sometimes for people to sort of get hold of, you know, what we actually do. But the thing that's important is that we supply solutions, trying to tie things together. So I've got a little bit of a graphic here showing the sort of challenge that everybody's been talking about and everybody's aware of. There's a lot of focus on where we're going to get to. You know, we've got to have a decarbonised future. You know, digitalization is something which will help us get there. Hydrogen is something that will help us get there. But from my point of view, what's really important now is we've got to sort of survive in the industry to get to that future. So a lot of the effort that I've been putting in, you know, at the moment with customers is looking at optimizing the processes that they have at the moment, trying to do that in a way which moves towards a future, but also gives some real benefit. You know, so examples of that might be looking at somebody's reheat furnace and making sure that the demands of the reheat furnace to reheat material is tied up with the demands of the production process, and the production process is really smooth. So that optimizes the amount of energy that you use to actually make your process. Simple things, but there's a real opportunity across the sector now just to do simple things to save energy and to combine processes together. Like I say, it's a nice graphic. It shows a whole load of things that we do. I'll just pick out a few. You know, we optimize rolling. We work to help people build pilot plants. There's a couple there right at the bottom of the screen on the right hand side. There's one we did for another academic institution, Imperial College in London, where we provided the complete control system for their pilot plant and helped them use that as a training aid. So it's something that we're comfortable in doing. We would love to be involved in, you know, supporting pilot plants and actually getting things off the ground so we get some real tangible results. I'm just going to flash through some of the stuff that we're doing now. You know, I'm not a metallurgist, but we have a very large metallurgy sort of department. We're really looking at what you can do to optimize, you know, arc furnaces by using electrical means. So that's electromagnetic stirring. We're looking at what you can do with casting processes using electromagnetic stirring. We're looking at how that actually makes real world savings. You know, it moves people towards the future. If you save energy now, it's a good thing. It makes some money to start looking at your digital future. But optimization, whatever happens, is really important in the process. So I've got some areas here which I'm going to go through quite quickly. Our first one, talked about digital. This is a customer with a melt shop, typical melt shop, lots of manual operation. We've got guys on cranes with paper schedules and, you know, everything that means from an energy point of view, things aren't connected together. And if things aren't connected together, you're losing lots of energy, you're losing lots of money. So the challenge is, how do you tie up cranes, ladles, schedules, movement of material, the best order to do things in a busy melt shop? How do you tie all that together? So we've got our smart melt shop. So this is it's real smart factory stuff. You know, we've got models to have a look at the thermal loss of material. We've got lots of tracking. We've got automation. You know, we've tied the whole thing together to create a smart factory. That means that you take people away from dangerous situations as well. So this is real. This has happened. This is in India. Some really big numbers coming out of it. So, you know, $2 million a year EBIT improvement. They're really big stuff. You know, $250,000 on your energy bill reduction. Really, really big stuff. And I think now this is a transition sort of technology. We can talk about getting to the future, you know, and what we're going to do with hydrogen in the future. But it's really, really important to have optimization now. Something we've been working on for a long while, using electromagnetic stirring. It's not new, but it's getting bigger and it's getting better. So this is where you actually sort of improving the quality in the arc furnace by using electromagnetism to stir. So you've got a big magnet sort of sitting underneath your furnace. And what that's doing is making a homogeneous sort of melt. You can sort of see in, let's move on, some of the stuff that we've been doing. You know, we've been applying this to really, really big stuff now. So this is a 450-ton electric arc furnace. It's big and it's working. And we have partners with Tata, where we doing stuff. You know, you're looking at big energy savings. It's a great technology now. It generally improves everything. You can apply it to older furnaces, and it has great payback. So transition technology, all about optimizing. Not really any excuse for not doing some of this stuff. Energy becomes more expensive. If the industry is inefficient, that's just a bad thing. Right, so moving on, same theme. So this is again using electromagnetism, and this is using it in thick slab casters. Again, for the same sort of thing, you know, you can use it for quality improvement.
Fields in the mould. One AC field controlling optimum flow speed at the meniscus for all casting conditions, and one superimposed DC field to dampen meniscus fluctuations. At the bottom of the mould, along the entire slab width, a second DC field minimises downward flow.
So what you're doing, rather than an abrupt ending to that, but again, you're using electromagnetism to improve quality and improve flow. It's something which I think can be applied in lots of different ways, and I think it's got quite a lot of time to run, this sort of stuff. So this is where we're working with Tata in Holland, trying to do some improvements. Moving on to what we can do for billet and bloom casting. Same, you know, electromagnetism, what can we do in the Tundish? Well, there's an opportunity to do exactly the same sort of thing, you know, non-contact electromagnetic stirring, either placed on the Tundish itself or on the manipulators on the outside. Make huge improvements in the mill, in the Tundish. A couple of examples I've got here. So this is a model we did, you know, using water, just to show how electromagnetic stirring works. So you can see on the right-hand side, you can see electromagnetic stirring in action, and on the left-hand side, you can see without electromagnetic stirring. And this is essentially what happens in the Tundish. And you can see how quickly you get a homogeneous sort of solution on the right-hand side. So just moving on from that, electromagnetic stirring some component parts. You've got a big converter. You've actually got the equipment underneath the Tundish, which makes the magnetic field. You've got some cooling equipment. It's not any different really equipment-wise from what you'd expect from a rolling mill drive, you know, and motor. Some benefits, you know, and this stuff's real. We've got pilot projects. We've got a couple of pilot projects going now. It really is working. You know, using it a little bit for metal powder production, you know, which people then use for making some, you know, putting material into hydrostatic presses to make homogeneous material. But again, something for the future. This is one of our pilot plants. See the piece of equipment fitted to the side of the Tundish. Just moving on a little bit. So whistle stop tour. I'm sorry I'm going very quickly. You can come back and look at the slides later in the recording. I think the previous speaker, you know, we talked a little bit about different technologies. You know, this is really about how we as ABB can help support some of these pilot plants. It's what we're doing with SSAB at the moment. You know, we're able to support with the electrical equipment, the control equipment, everything you need to build your pilot plant. I'm very excited to be involved in it. So this one is hydrogen breakthrough technology. It's hybrid for SSAB. You know, hydrogen, what you need for green hydrogen, you need some really big sort of high power rectifiers, lots of electrical equipment. Again, we can support that, and we can support the industry firstly by supporting pilot plants with equipment, and then supporting as it goes into proper production, supporting it with delivery of projects. A little bit here. It's another sort of one we've done in France. Again, we support with the electrical equipment. So thank you very much. Real whistle stop tour. Main thing, I think, is don't forget about the bit between now and the future. Have to optimize things, really have to get on with it. So there's no time to waste. So thank you very much.